If you're writing something like this in your code, this is your chance to learn a better and more adaptable way. And the new combat in Pokémon Z-A will help me explain it to you. Actually, we all start from this. If the battle type is story battle, we do this. If it's a wild battle, we do that. And if it's an online battle, we do this other thing. It can work, but there's something you might be missing if this is the only way you know how. What happens when a new requirement comes in, or you want more flexibility, or you want to test a new system? You can continue adding to this if statement, but it can get messy so fast. So let's take a look at the new Pokemon game for a second, and see why it's a good example to help explain the solution to this problem. When I want to write a program that needs to perform one task in multiple ways, my mind immediately jumps to the strategy pattern. Strategy pattern, what is that, you ask? The strategy pattern is a behavioral design pattern in programming. To put it simply, it's a way to create multiple options that are aiming to achieve the same thing, but they do it in different ways. This way, the main program logic is less focused on checking what it needs to do, and it's more about writing what it should do. If you're not following yet, that's okay. This is where the Pokemon analogy becomes useful. First, let's set the context. Not many game series have been running for as long as the Pokemon series, and that's something. But today, I'm only focused on the battle system of the games. For 25 years, the series had only one battle system, a turn-based system. You play as a character who's a young, up-and-coming Pokemon trainer, controlling a single Pokemon at a time in turn-based battles, where you select one of 4 moves. This system is the foundation of Pokemon, and the developers of the game have always been adamant about not changing it. But then, Pokémon Legends came out. And now, you could move the character during the battle. Just to be clear, this is still a turn-based battle system. Now skip forward to today, and we have a new Pokémon Legends, Pokémon Legends Z-A, another game in the Legends series. And it's doing something new. They're using this real-time system, and it's actually pretty cool. But we're not here to talk about the games, so why am I explaining all this? Well, when I saw this new battle system, it literally made me think of the strategy pattern. Give me 10 minutes and I'm gonna show you why. Like I said, the strategy pattern is perfect for making a piece of your program work seamlessly when different options are needed. So I've introduced these 2 different battle systems. Let's call them turn-based and real-time. But what if I was making the game, and I wanted it to have moments when it uses one of the systems or the other? How would I do it? I think you know where this is going. The 2 systems are different, but they're also similar. You still use Pokemon to battle other Pokemon, and you still choose moves to attack, defend, and use other skills. The 2 systems are just different ways of achieving the same goal. So imagine this scenario. My version of the game will have a story, wild, and online battles. The story and online battles will use the turn-based system, and wild battles will use the new real-time system. I'm going to organize and structure the code for each battle system so that choosing which system to use and interacting with the code becomes easy and intuitive. This is where I use the strategy pattern. Like I said before, both battle systems have something in common. To keep it simple, let's say both can start and end the battle. So I can take care of that first, using an interface to represent the similarities. After that, I create classes for both battle systems. And these will implement the interface I created before, which just means that at a minimum, they must implement the same functionality as the interface. This is the key to this pattern. The different battle systems will pass as a version of the interface, which means when you refer to the interface, you also refer to the classes that implement it. So now, our strategies are kind of like our own little Pokemon team. In the end, they're just trying to achieve the same goal, just like the Pokemon are battling to win the fight. This is why this pattern is different from creating 2 different battle system functions and deciding which one to call with if statements. Because if I did that, the code wouldn't work when I say start the battle. I would have to run a check on which mode should be used, and then I would have to use the specific function. Even if somehow the start battle functions were named the exact same, they wouldn't be treated as the same thing. You can make analogies for this pattern from almost anything. You could make each Pokeball a strategy to calculate the catch rates differently. You could have the normal and tall grass from the 2D games be strategies, so you can calculate the spawn chance of Pokemon differently. Or even use it to control NPC behavior, like having stationary NPCs or ones that walk around or follow you. All of those could be strategies. But if you still don't get it, that's fine. In the beginning, it was hard for me too. When you're writing code, you're focused on this one line. To implement the pattern like I explained, you would have to stop writing that line of code, maybe create new files, write the new code, and then come back to the line you were on. It can feel slow at first, but the good news is, just like playing games, you can get better with time and practice. But until you get there, I have some example code for the strategy pattern and some tips I think are helpful. Here we go. Make sure you take notes on the patterns you learn. Write them down in your own words, their names, and when and why you would use them. Having these notes ready to go can be really useful. When you go back and check your notes, hopefully you will see keywords that help you decide if you can use a pattern to solve that problem or not. After writing notes though, only practice can help. Trying things out, even on a small project and then coming back to it later, really makes it stick. It's the classic spaced repetition. Search that one up. And because you should try this new skill as soon as possible, I wrote some example code that can help you get a grasp of the strategy pattern. Check the description to download the Python file so you can follow along, but you can also save this video and come back to it later if you can't right now. So in this example, it works just like how I explained in the video before. The goal is to implement the strategy pattern so we can organize all of the different logic for each battle system in their own classes, and then we're going to use them via the interface we create. First, we have this interface called battle system. This interface represents everything the different systems have in common, like start battle and end battle. The actual logic for how each system behaves is going to be found inside the turn-based system and real-time system classes. You can see they can both do all the things we said our battle system can do. But when the turn-based system runs, I can enter a command to make my Pokemon attack, and once I confirm, the turn plays out and my opponent attacks back. And when the real-time system runs, the opponent can start and continue attacking, even if I never give a command to attack back. Now, the code we write to start the battle is quite simple. We create a function and make the parameter the system we want to use. And inside it, we can just refer to the parameter and call the class method start battle. See? No ifs and no else's in this code. This works because we already established that anything that implements the interface, battle strategy, must do something when we call start battle. And now the rest of the code is just the actual game loop that plays out to demonstrate these battle systems. I recommend looking at the source code and seeing if it all makes sense. I purposely wrote it to not be the best of the best, believe me. That way, you can take this, try to understand it, and even try to make it better if you're feeling adventurous. Just remember that in this example, there are only 2 strategies, but imagine if we had a lot more. That's when this pattern really shines. But that's it. I think that's all you really need to understand the strategy pattern. After this video, there's a lot more to learn about patterns. Not as much as the number of Pokemon that exist, but hey, that's actually a good thing. I'm sure you don't want to learn 700 plus patterns in their names. Or is it 1000 plus now? I don't even remember. I have another video on my channel that goes more in depth about the strategy pattern, in case this one didn't spark your light bulbs. And as a bonus, I can recommend the Refactoring Guru website. It really helped me a lot when I was first learning about patterns, so check it out if you have time. That's all for now. See ya. Have you played Pokémon Z-A yet? Did you find any other programming patterns hidden in it? What about another game? Let me know in the comments. And let me know if there's a game you think I should take programming examples from next, also in the comments.